if you have a numerical solve. Okay, go ahead and do this next one on your own. All right, so we are again focusing on an angle and its opposite side. This means that 27 needs to go on the outside of the equal sign, and then 16 and 21, it doesn't matter which one goes in for which. Plugging this into your numerical solve, you should get that theta is equal to 93 degrees. Okay, I would like for you to do this example on your own. I will check it when I see you in class. This is what I am looking for when I'm going to be checking your homework to make sure that you did it on your own. Last example, we have a bearing problem. So we practiced bearing together the last time we were in class, and this is where it starts to get complicated, but this is really the reason why we practiced it last time. And so what we're doing is we're now working on bearing, but not with right triangles, with non-right triangles. And this is typically how it pops up in the real world. So an airplane flies 280 kilometers on a bearing of 9 degrees from Calgary, Alberta, in Canada, to the provincial capital of Edmonton. The plane flies 1,320 kilometers on a bearing of 72 degrees then to Churchill, Manitoba, located on the shores of the Hudson Bay. So we need to first figure out the drawing. So I've got down here Calgary, and I want to go at a bearing of 9 degrees, which is a really, really small angle. And we'll do it here. This angle right here is 9 degrees. And then moving out from this guy, we're going at a bearing of 72 degrees, which is not quite 90, but it's pretty far out there. And that means that this guy right here is 72 degrees. We then go for a certain amount of distance and we end in Churchill. And then it wants to know how far is Churchill from Calgary. So we want to know this distance. It also tells us that the airplane flew 280 kilometers this way, and then it flew 1,320 kilometers that way. So what we have here is two side lengths, and we're missing the third one, and it's a non-right triangle. And then we're given a bunch of angle information. I'm going to focus on this angle situation just to the side over here. So I've got a piece here and a piece here, and each time I'm drawing a north-south line. So this north-south line is here, and this north-south line is here. This is the distance that was traveled. And it's a little bit skewed right now, but I want you to see why it's skewed. This is our 9-degree angle. And we know that north to south must be parallel. It is always north to south along the map. Since we know that those are parallel, we can then start using parallel angle relationships. You don't have to remember what they're called. You don't have to remember whether it's called corresponding or alternate interior or corresponding angle or same side interior. But you do need to remember that the small angles in this situation are equal and the big angles add up to 180, right? So if I was trying to solve for this one, I would do 180 minus 9. But I want you to notice that this angle right here is this angle right here. This guy and this guy are the same situation. So I can label this as 9. And that is really helpful because we now can solve for the rest of this angle because 72 and this angle minus that little 9-degree sliver, these two add up to 180. So if I took 180 and subtracted out 72, I would get 108. I'm sure you're freaking out just a little bit. We're going to practice this in class. But I want you to realize in class that there's a parallel angle relationship here, as well as linear angles, solving for linear angles, 180 minus 72, understanding that alternate interior angles are equal. As long as you realize that that's the situation going on in here before you come to class, then you'll be set up for success after the end of class, okay? So we've got 108 and 9, both as these two little parts to the angle. In order to figure out what the total angle here is, we need to add them together to get the total angle. It's getting really messy, so I'm just going to redraw this triangle in a way that is easy for us to see. We want to solve for x. We know that this is 280, and we know that this is 1,320. We just solved for this angle. It's 108 plus 9, which is 117 degrees. We now have all the information we need in order to solve for that side length. This is the angle and its opposite side. So x squared goes on the outside, and then it doesn't matter which one's 280 and which one's 1,320. So I'm going to do 280 squared plus 1,320 squared minus 2 times 280 times 1,320 times cosine of 117. So we get that x squared is equal to, and that's a really big number. It's in scientific notation. Notice it has this e here, which means it's in scientific notation. So I could even write it in scientific notation, 2.16 times 10 to the 6th power. I know I need to take the square root of that guy, so I'm going to just scroll up and press enter. Bring it down, which means that we get that x is equal to 1,468.47. It doesn't tell us how many significant figures we should round to. A good guess is always 3. So we're going to say that x is equal to 1,470 kilometers. Okay, if an airplane flies at an average speed of 720 kilometers per hour, how long is a direct flight from Calgary to Churchill to the nearest hour? So if we're talking about 1,470 kilometers, and it takes 1 hour to fly 720 kilometers, we then can solve it in that way. Okay, we're trying to convert, so we know that the kilometers need to cancel out, and we know that it's 1 hour to 720 kilometers. So we're actually going to be dividing these guys. So I'm going to take this, I'm going to divide it by 720. And we get that it equals 2.04 hours. So 2 hours to then fly from that distance. All right. Good job today.